Hello, am I audible, guys? Hello, is anyone there? Okay, I think I'm audible. So I'll start. All right. Hi everyone. My name is Pradyumn, and today we'll discuss the today's Leetcode contest. We'll solve the all the four problems. Before we start, I would like to tell you about the CP31 sheet. Um, for all those who are not aware, this sheet contains 31 problems in each rating from 800 to 1900. Our sheet has now been upgraded with discussion sections and even a leaderboard where you can um, check out that how what is your rank among all the people who have solved the sheet. Also, it has been integrated with the automatic code forces linkage. So whatever problems you have solved on code forces, they will reflect here as green. So you won't have to see them again. Added to this, every week, 7 to 8 video solutions will be uploaded. So no more wasting time finding the right problems. The link to the sheet is in the description of the video. So let's start with the PC data. All right. So the first problem is um, find special substring of length k. You are given a string s and an integer k. Determine if there exists a substring of length exactly k in s that satisfies the following conditions. Okay. The substring consists only of one distinct character. That is, entire substring has the same character. If there's a character immediately before the substring, it must be different from the character in the substring. And if there's a character after the substring, it must also be different from the character in the substring. Return true if such a substring exists, otherwise return false. So if there's a substring like that, then return true, otherwise return false. Okay, so just a minute. Yeah, so the problem is like we have been given a string, right? And we have to report a substring of length k. So an integer k is also given. So we have to report a substring of length k such that all of its characters are same. So let's say k equal to 3. Then these three characters have to be same. And also the previous character and the next character has to be different from these three characters. So we have to report a substring that satisfies these conditions. All basically we have to just return true or false, that does it exist or not, right? So what we can just do is we can, since the constraints are very low, we can also do it in O of n into k. So n and k are up to 100 only. So even solutions like if we do it in O of n into k, or yeah, so like that, that also pass. That will also pass. But so how can you do it in O of n into k? That is also like pretty easy. Basically, you can just iterate over entire string. So just iterate over the starting index. So let's say the string is like this. So first you will check this string. Let's say k equal to 3. Then first you will check this string, that does it have all the same character or not, right? And does it have the different character here or not? So that will take O of k time, right? Because we are iterating in this k length. So O of k for the first one. Then you will check for the index second, right? You will check for this index. So that will also take O of k time, and so on. You can do up till here. So this index is n minus k. So you can do that up to n minus k. So it will take time n minus k into k. right? So that's one method of doing it, but it is like slow because it will take O of n into k time. So we can actually do it in like even more efficient way. What you can just do is use sliding window technique. What is sliding window? I think you all might know. So first of all, we basically will keep a frequency array. Okay. So we have a frequency array of all the characters from A to Z, right? Denoted by 0 to 25. So starts with 0 and ends with 25. So in this the frequency of I will be the frequency of character I. Okay. Like in the current substring. So let's say we consider the first substring, which is of length k equal to 3. So we just iterate over this and add the like count the frequency of each character, right? Then what we do is we check that, okay, is the frequency of this character equal to k? Like let's say a is here, then if frequency of a is equal to k, then what does that mean? That means that all of the characters are equal to a, right? In this substring. So you just check that, and also you will check that this character is not equal to a. Okay. So if that is the case, then you just return true because you have found substring. Now what you will do is you will check the next one. You will check the next substring, right? So you will check this one. Now how do you do that? Like uh, in less than O of n into k. So you can't. So like if you don't want to do it in O of n into k, then how you will do? So you can basically slide this window from here to here. So what does that mean? You can just reduce the frequency of this element and add the frequency of this element. So whatever letter is here, let's say C is here, so you will just do fr of C plus plus. I mean, the frequency of C will increase. So that's how you can apply a sliding window here. And at each point, so let's say you are checking for this one, then also just take this character and see what is the frequency of that. Frequency of, let's say here is C, those frequency of C. It will be at least one, right? It will be at least one because one of the C's is here, and if there are other C's, there will be more. So if it is equal to K, then definitely all of these characters are equal to C. So you can identify that, okay, this entire subarray consists only of C, and then you can just check this character and this character, that do they consist only of C or not. Sorry, I mean, are they not equal to C? So they should not be equal to C. That is a condition, right? So if that is so, then you just return true. Otherwise, iterate and look at this window next, and so on. So this will take O of n time because you are just using a sliding window. That is one for loop. When I show the code, it will be much clearer that why is it O of n. But right now, this is the solution, right? So I hope that is clear. If it is clear, just put a yes in the chat. Okay. So let's move on to the code now. Yeah. So this is the code. First of all, what I did was just make a frequency array. So initially it is empty. Now I'll first handle the first k characters. So let's say we have this array. So I will first loop through the first k characters and insert their frequency into it. So int I equal to 0, I less than k I plus plus, and frequency of s of I minus a plus plus. Alright. If s dot size is equal to k, okay, so this is an edge case. Like if n equals to k, then this entire string is equal to the value of k, right? So in that case, what do we have to do? We just need to check that is all the characters the same in this string. So if frequency of s of k minus 1, that is the last character is equal to k. If that is equal to k, then return true. Otherwise, return false, because not all the characters are same in that. Okay. So this is an edge case here. Okay. So now I just check that this first substring of length k, is it satisfying. So for that, this should be not equal to this, right? And the frequency of this character should be equal to k, right? So if frequency of last character is equal to is equal to k, and s of k is not equal to s of k minus 1, then return true. So the first substring is satisfying, right? Now I just iterate, like now I just slide this pointer. So I start from this k, so that means this window, then here, so this window. So till the end I iterate. So I equal to k, I less than s dot size I plus plus. Now what I do, let's say I am here, then I have to handle this window, right? So I just decrease this frequency. So if I am at index I, so I will decrease I minus k, right? So fr of s of I minus k minus minus, and fr of s of I plus plus. So at the ith one, I increase. Now I have to check, right? I have to check that is the entire window of the same character. So for that, I am using this condition: fr of s of I is equal to k. So that is one condition. But also we need to check that is this character, like if we are considering, let's say this one, then this character has to be different from this, and this has to be different from this, right? So if s of I minus k plus 1, which is this character, is not equal to s of I minus k, which is this character, right? And s of I is not equal to s of I plus 1, right? Or it can also happen that we are at the end. So if we are at the end, like if we are considering this subarray, then that means we don't need to check this one, right? We don't need to check, I mean there is no element here, so we don't need to check that. So if I is equal to end, like s dot size minus 1, or s of I equal not equal to s of I plus 1, then both of these conditions are satisfying. So if these three conditions, like the first condition is the left one, second is the right one, and the third one is that all should be same. If all of these are satisfied, then return true, right? And if in this entire for loop, if we weren't able to return true, then return false, right? Okay, so I hope that is clear. So is it, if it is clear, then we'll move on to the next one. So is it clear, everyone? Can we do Python? I actually don't know Python that much. I do in C++. So if you want Python codes, then you can view other submissions also, like maybe some solutions. Okay. All right. So let's move on to the next problem. The time complexity of this is O of n. Like as you can see that, see this is one for loop of k. So we have k. Then what we have? There are no loops, and this is also just O of one condition. And finally we have this loop. So this loop runs from k to n, right? And like here just O of one operations are performed. So k plus k to n, right? So n minus k. So this is n. So the complexity is O of n, because we are running just O of n loops. Okay. Yes, sliding windows with hash map, that is also what I did. Basically, instead of hash map, I just used an integer array. We don't need hash map because the elements are contiguous. So like A to Z, their ASCII values are in the same range. So we can use an array, simple array of 26 length. All right. Anyways, so we'll move on to the next one. The second one is the question says you are given an integer array pizzas of size n, where pizzas of I represents the weight of the ith pizza. Every day you eat exactly 4 pizzas. Due to your incredible metabolism, when you eat pizzas of weight W, X, Y, and Z, where they are in ascending order, you gain the weight of only one pizza. On odd numbered days, you gain a weight of Z, and on even numbered days, you gain a weight of Y. Okay, so find the maximum total weight you can gain by eating all pizzas optimally. Note that n is guaranteed to be a multiple of 4 and each pizza can be eaten only once. Okay, so there are some pizzas, right? There are some pizzas like n pizzas. Okay, uh, we have, okay, let's say n is equal to 8. So we have 8 pizzas, and each day we can eat 4 pizzas. So 4 pizzas each day. So, and let's say we ate pizzas of weight X, Y, Z, and W such that they're in ascending order. Like they are in ascending order in this way. Then, if it is an odd numbered day, so like on the first day, the third day, the fifth day, and etc., our weight will increase by Z, right? And on the even days, like second, fourth, and sixth, our weight will increase by Y. So let's say on the first day, if we eat 1, 3, 2, and 4. So on the first day, if I eat these pizzas, then my weight will increase by 4. And if on the second day we eat these pizzas, then my weight will increase by 3. The second highest element. Okay. So yeah, that is the question, and we have to maximize our final weight, like the maximum total weight you can gain by eating all the pizzas optimally. So we have to eat all the pizzas, obviously. Like even if we weren't given a constraint to eat all the pizzas, obviously we would eat all the pizzas because we want to maximize the weight. And pizzas have positive weight, right? They have positive weight. So obviously we'll eat all of them. Okay. So if you carefully analyze this thing, the difficulty here is that on even number days you gain a weight of y, right? So y is the second highest. Like if it is an odd number day, we gain a weight of the highest pizza, right? And if it is an even number day, we gain the weight of the second highest pizza. Okay, so that is the problem, right? That even if we ate a heavy pizza, it won't be counted. It will only be counted on odd numbered days, and on even numbered days it can only be counted if there is one more pizza which is heavier than that, right? So that is the problem here, that we are not able to count the heaviest pizzas, all of them. So let's say it was not like this. If the question was like on odd number days and on even numbers days, both of them, like on both the days we gain weight of z. If we eat 4 pizzas on all days, our weight increases by z, which is the highest pizza, the heaviest pizza. Then what would be the answer? Like if the question was that, then what would be the answer? So let's say we had some pizzas. Let's say we had 1 to 8, 1, 2, 3, 4, 5, 6, 7, 8. So in this case, what is um, what is the number of, what is the maximum weight that we can achieve? Like if in every day you are only able to eat the highest pizza, I mean, if you eat 4 pizzas and you gain a weight of the highest pizza, then what is the maximum weight that you can achieve? Someone says 14. 8 plus 6. No, like, can't you have 8 plus 7 also? Yes, 8 plus 7, right? How? Because first, like in one of them, you will just choose highest as 7. So let's say you choose 1, 2, 3, and 7. So you will gain this weight. And then in the other day, you will have highest as 8. So you will choose, let's say, 4, 5, 6, and 8. So if the question was like, yes, if it is every day, highest weight, then you can have 7 and 8. Or in general, you can have the last n by 4 elements. So like, if you sort the pizzas by weight, so if there are some pizzas, and if there are n pizzas, it will take you n by 4 days, right? N by 4 days to eat all of them. So at max you can have only n by 4 pizzas. Like the weight, like in one day, the weight of one pizza will be added to your weight, right? So at max n by 4 days, you can only have n by 4 pizzas. So what you will try to do is take the last n by 4 pizzas, right? And that is actually possible. If, like in my question, in my modified question, it is actually possible to take the last n by 4 pizzas. How? You can just take one from here, then 3 from here, then one from here, then 3 from here, then one from here, and then, like, I have drawn less brackets, so that is one issue. So 3 from here and one from here and then 3 from here. Okay, so that's what you can do. That's how you can choose the last n by 4 pizzas, and your final answer will be the sum of weight of all of them. So that's the maximum weight you can gain. But if you are not, like, if you are not allowed to take the heaviest pizza, so let us move on to the original question. So on even number days, you will gain a weight of y. So what does y mean? Y means that you are like the second highest element. So basically, you are eating two pizzas, but you are not able to add this weight. The heaviest weight you are not able to add. So basically, if you want to add a weight to yourself, then you need to sacrifice another weight, a heavier weight. Okay. So it is something like, let's say n equals to 12. Okay. So I'll draw 12, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. All right. So n equals to 12 means n by 4. So n by 4, which is equal to 3 days. For 3 days, you will eat pizzas, and each day you will eat 4, right? So on the first day, it is an odd number day, so you will get the highest weight. On the second day, you will get second highest day, and on the third day again you will get the highest pizza. Sorry, second highest pizza, and the third day you will get the highest pizza. So if you eat, like if you start eating from here, let's say you want to, like, take this one and this one, so that is not possible, because on the first day, let's say you take this one, and with it you take the waste elements. So I am calling these one as waste. So let's start from the lower ones. Okay, so yeah, first of all, this is sorted, right? This is sorted in ascending order. So let's say on the first day you want to eat the heaviest pizza. So you will first take this one, and also you will take the lighter ones, so that the weight of the heaviest pizza is added. So now these 4 pizzas are eaten. These 4. Now you want this pizza on the second day, but that is not possible, because on the second day, if you want some pizza, then you have to eat another pizza that is heavier than that, and that weight won't be counted. So if you want to eat this, then you cannot, because there is no pizza heavier than that. So you will try, let's say if you try to eat this one on second day, so if you want to eat this one, then definitely you have to eat this one also. Like if you want the weight of this to be counted, you have to eat this one as well, because then only this will be second highest, right? So this is 11, this is 10, and this is 4 5. So if you eat 4 5 10 11, then only 10 will be counted. Let's say if you ate let's say if you just ate 4 5 6 and 10, then this 10 won't be counted because it is not the second highest. So now, as you can see, if you eat 4 5 10 and 11, then this 11 is wasted. So when you eat 11, 11 is wasted, and 10 is taken. So this 12 is taken and 10 is taken on the second day. And on the like third day, if you try to eat, like now what will you eat? Now you will just eat this one, this one, this one, and this one. So actually this is one way, but this is not optimal. So like if you do it like this, then what is the final answer? I'll just make a new diagram. 6 7 8 9 10 11 12. Okay, so first I am saying that you ate this one on the first day, and maybe these three, like they won't be counted. Then on second day you need that second highest element, like you can eat second highest. So let's say you eat this one, and these two, then you will had the weight of this one, and these pizzas won't be added. And on the third day, let's say you eat this and this. Okay, so in the end you end up with like this is 11 12 13 and 14, right? So you end up with 11 plus 12 plus 14, which is equal to 37, right? So that is one way, but this is not optimal. Why? Because we have another way. So what we can do is 6 7 8 9 10 11 12. So in this example we actually took the highest, the third highest and fourth highest, right? But it is possible actually to take the two highest elements and the fourth highest. How? So what we can just do is, on the first day highest and third day highest we can eat, right? So what we'll do is, on the first day we'll eat this one, and on the third day we'll eat this one. So while doing that, six pizzas will be gone. 1 2 3 4 5 and 6, and these two. So the weight of these two will be added. And on the second day we will have to skip this one, right? We have to skip this one and eat this one. Like we have to eat both of them, but the weight of this one will be counted, and these two will be skipped. So finally the answer becomes 11 plus 13 plus 14. So it becomes 38. So 38 is better than 37. That's why this is this is like more optimal. So in general, actually, what you can just do is the number of odd days. Like one is an odd day, three is an odd day. So you can eat the highest in that, right? So what you will just do is just eat the highest odd elements. So let's say n was equal to 20. Okay. So that means n by 4 is equal to 5. So you have 5 days. You have first day, second day, third day, fourth day, and fifth day, right? So on the first, third, and fifth day, what you will do is you will eat the three highest elements, the three highest pizzas, the heaviest pizzas. Okay. On the first, third, and fifth day, and on second and fourth day, you have to sacrifice a pizza, right? So what will you do then? So I'll just draw it. 1 2 3. I'm just drawing the highest ones. Okay. So this is like 20, 19, 18, and so on. So 17, 16, 15, 14, and so on. Okay. So on the first, third, and fifth day, you will eat 20, 19, and 18. Now what you have to do, you have to sacrifice a pizza, right? Like basically on second day, you cannot have the highest weight. You have to sacrifice the highest weight. So you have to sacrifice this one, but you can eat this one using this. So if you just eat 16, 17, and let's say 1 2, then you are sacrificing 17, but you are adding 16 to your answer. So sacrificing 17, so and adding 16. So 16 is added. Then, so this is on second day. And on fourth day, what you can do? Sacrifice this one and take this one. Right? So that's what the correct answer in this case is. So like the correct answer is 14 plus 16 plus 18 plus 19 plus 20. So whatever this value is, so 30 plus this is 37, 67 plus 20, 87. Okay, so that is the answer in this case. So if you can like think about it, the general strategy is now known to us. Like let's say n is something. Okay, so I will just calculate the number of days. Number of days is n by 4. Let's say that is k. Okay, that is k. So how many odd days and how many even days do we have? So what we have is the first day, second day, third day, up to kth day. So number of odd days, what are they? First odd day, third one is odd day, fifth is an odd day. And if let's say if k is equal to odd, then it is like let's say k equal to 7. So 1, 2, 3, 4, 5, 6, 7. So 1, 3, 5, and 7. So we have 4, right? So basically it is k by 2 ceiling. The ceiling of k by 2, the number of days, the number of odd days, and number of even days. This is odd days, and number of even days is the floor of k by 2, right? So what we'll do is on all the odd days we'll eat the highest pizza. Okay, so we had n pizzas, right? We had n pizzas. So we'll eat the last O. So let's say this is equal to O. So we'll eat the last O heaviest pizzas. Now what we have to do is, so these are the odd days pizza, and on the even days what we have to do, we have to skip one pizza. So we have to skip this, then eat this. So this is on the first even day. Then on second even day we have to skip this and eat this, then skip this, then eat this. So we have to do it e times. So basically uh, we have to do it e times. So this one and this one total, we have e pizzas. We have eaten e pizzas. So we can just do alternate, like we can traverse the array in reverse. So when we do that, so we traverse the array in reverse, we'll do like the last element, second last element, third last element, fourth last element, up to like o elements. Then we'll alternate. So we cannot take this one, but we'll take this one. Then we cannot take, but we take. So let's say we just keep a pointer here. So we'll start I equals to uh, n minus o minus 2, right? Because this length is o, so that means this is n minus 1. So this will be n minus o minus 1. So this will be n minus o minus 2. So I'll start I at n minus o minus 2, and I will do I minus equals to 2 up till like e times. So starting from n minus o minus 2 and ending at while I is greater than or equal to n minus o minus 2e, right? So how 2e? Because on the first we take n minus o minus 2, then we take n minus o minus 4, then we take n minus o minus 6, and we want to take e terms, right? So first term is minus 2, second term is minus 4, third term is minus 6. So the EH term will be n minus o minus 2e. So we'll take the array elements up till here. So that is our final answer. That last O elements we'll take, and then these E elements we will take. So we'll just make a for loop and add this to our answer. Okay. So yeah, that is the logic here. and I'll just show you the code. So the code is like k equals pizzas dot size by 4. Okay, so k is the number of days. Sort, I just sort the array, and n equals 4 into k, right? And ans equals to 0. Long ans equals to 0. Now I'll just take the last o elements. So last o elements I'll take. So I equal to 0, I less than o, I plus plus. So o is ceiling of k by 2, just k plus 1 by 2. So ans plus equals pizzas of n minus 1 minus I. So the last element, second last element, third last element, and so on. So this counts the last o elements, and then I will start with n minus 2 minus o, and I just kept another count variable. So count equals to 0, and while count is less than e, so this is e, right? K by 2 ka gif, this is e. So count less than e, so I'll do I minus equals to 2 and count plus plus. That's what I'm doing, that I equals to n minus o minus 2 and I minus equals to 2. Ans plus equals pizzas of I, and then I'll just return ans, right? So that's the final code. So does everyone have like understood this solution, or do you have any doubts? Can you can ask doubts now. Rank is 7k. Is this good? So like I can't really comment because it depends on like how much, like how, what is your skill level right now, and like how much you have done DSA. Three wrong answers. Yeah, like I was half asleep while giving the contest. So like any doubts, any other doubts related to the logic or the code? Okay, so I'll move on to the next one. All right, this actually is a nice question. So, given a string s of length n and an integer k, determine whether it is possible to select k disjoint special substrings. A special substring is a substring where any character present inside the substring should not appear outside it, and the substring is not the entire string s. So, they have defined a special substring that, okay, you are given a string, you have been given a string, and this substring is special if and only if all the characters that appear inside this substring do not appear outside it. So let's say there is ABC here or ABB here, then there should be no A or no B outside the string, outside this substring. So all the B's and all the A's that are there in the string, they have to be in this substring. If that is the case, then this one is special. Then we call it special substring. Okay, so that's what they have defined. So we have to select k special substrings, right? And they have to be disjoint. So they can't be overlapping, okay? So we have to select like this, and this maybe. But we cannot select like this one and this one. So they cannot overlap. Okay. Return true if it is possible to select k disjoint substrings, otherwise return false. A substring is a contiguous non-empty sequence of characters within a string. So substring is, you know what a substring is, right? So we will like try to solve this. All right. And yeah, the limits of n and k are like n is up to 10, n is up to 5 e4. So definitely n square is not expected here, right? and obviously k is still 26. I'll explain why that is in just a minute. So yeah, that is the constraints. So we have to solve it in O of n or O of n log n or something. All right. So just think about that. What can we do here? Okay. First of all, the observations. Let's look at the samples. Okay. So A B C D B A E F A B A B C D B A E F A B. So here A is here, A is also here, and A is also here, right? And we want that all occurrences of A are inside a substring or not inside a substring. So a special substring is called when all the occurrences of all the characters are inside the substring, right? So what does that mean? That means that if I take this A, like if this character is in my substring, if this character is in my substring, then that means that all of these A's should be there. So the last occurrence of A also has to be there. So at least I have to take this, or I cannot take this character, right? Like if I want to take this character, I'll take it, but I also have to take the entire thing till here. Okay. So that's the observation here, that if we want to take a substring like this, then we have to take the entire thing. But also now you see that if we want to take this entire thing, then B also happens to be inside here. So we have to also take this last occurrence of B also. So actually we cannot even take this substring. We have to take we have to take this entire substring, and this is not special. It is not special because special substring cannot be in the entire string. That is one condition. The substring is not the entire string, then only it is special. So therefore this is not special. So therefore definitely we cannot take the first index, because if we want to take it, then we have to take the entire string, like till here, and also we are taking B in this, so we have to take this last element as well, but that is not possible. So that's why we cannot take this A. Now if we try to take this B, then we can. So if we try to take this element, we need to take the all the B's, right? So till here also we need to take. So if we go till here, then we have to take it. But then A occurs within substring, so we have to take this A as well. So again, this entire substring have to take, so we cannot do that. Now, if we want to take this C, then what we can do? We can take this C, and there is no other occurrence of C, right? So we can just take this substring as one, right? So that is the C. Like that is one special substring because there is no occurrence of C in except for this one. Now let's say we try to take D as well. So if we try to take D, there is no occurrence of D any other in any other place, right? Now so we can take this D as well. So actually we have found the answer because K was equal to 2, right? K was equal to 2, and we have to just find two substrings. So we have just found this C and this D. So that is the final answer. That true. True, because we are able to find two strings or two substrings that are like disjoint and special, right? So that's the answer here. But also let's just complete the process and try to find even more. Okay. Now let's say we want to take this B. We want to take this index, but we actually cannot do that, like because we have to take this B as well, right? Like basically, since this B is not the first occurrence, so it is not possible to just take the suffix. Like it is not legal to even take this full array because there is one occurrence of B as well here. So I am saying that since this position is not the first occurrence of B, we cannot start from here. The substring cannot start from here because there is one B behind it as well, right? So actually, while dry running like this, we came across one observation that all special substrings must start with the first occurrence of that character. So what I mean by that is that a substring cannot start at here. It cannot start here. Why? Because if it starts here, then doesn't matter wherever it goes, there is one B here as well. So we are never not able to take that because we are starting from here. So doesn't matter till where we go, we will not be able to take this B. So therefore, one observation that we have, all special substrings must start with the first occurrence of that character, right? So that's a very good observation that it can help us optimize our approach. Okay. So this is one thing here. So now what we can do is uh, we cannot start here, right? So we'll skip that. What if we want to start here? We cannot do that because it is not the first occurrence of A. So the first one is this, right? Now let's say we want to start here. So till where can we go? We can actually go till, like, basically we don't have to go anywhere because the only occurrence of E is this one. So we will remain here only. So this is also a good substring, right? Now let's say we want to start from here. Then till where can we go? Like, we don't have to go anywhere because the only occurrence of F is this. So we can take this one as well. And we cannot take A, we cannot take B because they have occurred previously. So basically these four substrings, C, D, E, and F, these four substrings are special and are also disjoint. So even if K was equal to 4, let's say, the answer would be true because we are able to find a substring, like we are able to find four substrings which are special, right? So one observation that we derived from this dry run was that always a special substring must start with the first occurrence of that character. So we cannot start with this B because if we start from this B, then doesn't matter where we go, we will never be able to take this B in the substring. Okay. So kind of this is the approach. So what you can do is just um, let's say you have this string. Let's just dry run on another test case. C D E F D C, or maybe we'll take this one. A B. Okay, let's just take C D E F D C. C D E F D C. So let's say we want to count that how many special substrings are there. Then how do we count? So let's say we want to start from here. If you want to start from here, then we have to take the whole one because this C is there, right? So we cannot do that. If we want to start from here, then we have to go till here, till D. So this is one substring. So uh, this is one possibility, right? But what if we don't start from here? Let's say we start from here, then we can take this one. And let's say we start from F, then we can take this one. So we can actually take two. So if K was equal to 2, then our answer would be yes, E and F. And actually, if K equals to 1 also, then also we can just take either E or F. But also we could take this DEFD string. Like, basically starting from this D, we have a string called DEFD. So yeah, like that is the thing. But the question now is that how do we actually count the number of such substrings, and that also in O of n. So what I told you, like if you just brute force that, it will at least take O of n square, right? But you need to do it in O of n or something, right? So how do you do that? Actually, let's say, like let's say you want to start from here, or let's take another example. Let's just take this example, or wait, let's say you have A B C D A X Y Z uh, Y Z. Okay, so let's say the string is this. So let us count that how many we can have, right? So first of all, let's say we have an E here also, or let's say we have a C here, or never mind. Okay, so first of all, this substring is actually good, and Y, okay, this YZ is also good. This special because we can have, like, all of the occurrences don't occur anywhere outside it, right? So we can find two like this. But how do we actually find it using code? Let's think about that thing. So first of all, let's say we want to start from here. Okay. So we have to go till here, right? So this is one substring. But if and now if we know that what is the answer for this suffix, like if we know that what is the answer for this part, then definitely we can just take that. Suppose the answer to this is ans, then the answer to this one will be ans plus 1. So we can kind of apply dp here, right? Basically, let's say we have abcda, and then we have a long string ahead of us. There are some many characters, and they are all there. So let's say we have already computed the answer to this one. Okay, so the answer to this is x, let's say. And then let's say we want to compute the answer for this entire string. All right, so if we start from here, then we have to take up to a, right? We have to take up to this a. So this is one string, and we already know that the maximum answer for this part is x. That basically there are at max x disjoint substrings. So the final answer for this entire substring is actually x plus 1. X plus 1 if we want to take a, like if we are desperately trying to take this a, then we have to take the entire substring, right? So we just take that as one, and the entire rest of the string answer is x. So the answer to this thing will be x plus 1 if we want to take this a. But let's say we don't take this a as a substring. Like if we don't take this a in a substring, then what will happen? Then basically it is just the answer to the this part. Like if we are computing the dp in reverse, let's say from here to here, then the answer to this part is already computed. So the answer to this entire, we can calculate, like how can we calculate that? Either we take this character or we don't take it, right? So if we don't take it, then the answer is just the answer to this part. And if we do take it, then we have to take this entire thing, and therefore the answer to that would be 1 plus the answer to this part, right? So this is the kind of dp that I'm talking about. So is it clear, like kind of the dp thing, like how do you exactly, like I will tell you that how do you implement this and how do you do it in O of n. But is the dp idea clear, that if you want to take this a, then you have to take this entire thing, and therefore the answer is 1 plus the answer of this. But if you do not take a, then the answer is just the answer to this. So you will consider those two things, and the it is the max. So we'll just take the max. So how many of you got this part, like the DP thing, the DP idea here? Okay, so I don't see any doubts. So I'll continue with my approach. Okay. So what we are trying to do is we are trying to compute the answer for every suffix. So let's say we have a string s. Then we are trying to find the answer that okay, for this substring, for this suffix, what is the maximum number of substrings that we can form, right? So how do you calculate that? Basically, either you take this index or you don't. So if you want to take this index, then you just find the minimal thing, that let's say there is ABA here. So if you want to take this thing, this A here, then you have to take this ABA in its entirety. So you can just find the answer to this one. So let's say this is C, this, and the answer to this is 1. Then the answer to this entire thing is actually 3. Sorry, actually 1 plus 1. Like, because you are taking this one, and the answer to this, the other portion is 1. So the answer to this is 1 plus 1. ABAC. Okay. So which is equal to 2. Like, basically you can take ABA and then you can take C. So that's the transition here. But actually you will only do this if this index is the first occurrence of A. Like, since there is A here, but let's say there was A somewhere here also, then definitely you cannot take this index as start, right? Because if you start from here, then you cannot take this A. So you cannot take this. So definitely the answer to this index will be the answer to this suffix as also. Like, the answer to this suffix will be equal to the answer to this suffix. Why? Because you cannot actually start from this A. So if you cannot take this A, then it doesn't matter that are you calculating for this range or for this range, because in both the cases the answer is same, because you are not taking this A as a substring, right? And if A is the first occurrence, then just calculate that till where do you have to go. Okay, so how do you actually calculate that? Let's see about that. So let's say we have a B, an A, uh, an E, then a B as well, and then an E, then let's say a D, and then a C. Okay, so now let's say you want that you take this A. All right, so what does that mean? If you are taking this A, then you have to take all of the A's, right? So whatever is the last occurrence of A, you have to go till at least that, right? So I just index this. Okay, 0, 1, 2, 3, 4, 5, 6, and 7. So what is the last index of A? It is 2, right? It is 2. So we have to go till at least 2. So let's say we end at some index E. Okay. So we have to end at index at least 2. So E has to be at least 2. Because otherwise you won't be able to take this A. If you end before that, you won't be able to take this A. Right? So E has to be at least 2. So you start at here. The pointer is here. Now you need to take at least 2, right? So you go ahead by 1. So you go here. So you have to take b, right? Since you have to go till at least 2, that means till here. So that means you have to take this b as well. So when you go to this b, then you will see that the last occurrence of this b is actually at 4. So now you actually have to go to at least 4, right? So that is the updated condition here. So earlier you knew that you are at a, so you have to take the last a. So at least 2 you have to go. Now you just check for this b. So for this b, the last occurrence is at 4, right? So you have to go till 4 at least. So this changes to 4. So now you'll go to this a, then you go to this e. So since you are taking this e, the last occurrence of e is at 5, right? So you have to go till at least 5. Then you go to this 4, then you go to this 5. Then so basically you have reached 5 now. Now you don't need to go any further, because up till now whatever we have discovered, like they wanted us to go till 5 only. So basically you have to go till here. So what am I saying? I'm saying that if you want to take this a, then just keep track of what is the maximum value that you have to go till. Like let's say you are starting from this a, right? If you want to take this a, then you have to go till 2. So you go, okay, so you go to the first index, so you take this, they take this b. But since you have taken this b, you have to take this b as well, the last b. So it is at 4, so you have to go till 4. Now let's say you go to a, so a is good, there is no other occurrence of a. Now you go to this e. So since you have taken this e, you have to take this e as well. So now we need to go at least till 5. So then you go to 4. So last occurrence of b is this only, so there is no problem. And then you go to this e, which is at index 5. So you have went till here, and you are only supposed to go till here. So that's why we have to go till 5. So this is the substring that we have to take. Like if we want to take this a, then we have to take up to 5. All right. And one more problem in this is that, let's say that there were some characters, let's say there was e here as well. Okay, so instead of ABAC, so the new string is EA BAE BEDC. Okay, this is the string. And let's say we want to figure out that starting from A till where we have to go. Okay, so starting from A till where we have to go, let's figure that out. All right, so let's start from A. Now I'll number this 1 2 3 4 5 6 7 8. So you start at A. Now what is the last index of A? It is 3. So I have to go till 3. So you go to 2. You look at this B. You can look at this B and say that I have to go till 5. So this 3 changes to 5. Now you look at this A. So A means A have to go till 3. Okay, so that doesn't matter. Then you look at this E, right? But then you notice that the first occurrence of E was before where I started from. So I started from 1, right? I am taking this substring and I have reached till E. So I have taken E in this. But the problem in that is I have not taken this E. So that means that actually I cannot start from A. Basically, we have reached a contradiction here, that this B wants that this B also is there. But if we start from here and we go till here, then we'll have to take this E also. So we'll have to take this E also. But then this E is left out. So that's why this is not special. Okay. So that's the thing that we have to like keep a check for, that if we are taking a certain character, like if we are starting from I, then all of the characters that we are taking, their first occurrence should not be less than I. Like their any occurrence should not be less than I. So just take the first occurrence. Okay. And that's how you will transition. So let's say there was not a E here. Like if there was not an E here, then it's not a problem. So we can just, let's say we have the answer computed till here. So we have all the answers till here, and we want to compute the answer for this index. Okay. So how will we compute that? We will just try to take this A index. We'll just try to take this A. So for that we'll have to take till here. For that we'll have to take till here and till here also. So this is the substring that we'll have to take. So till 6, so 1 to 6 is one substring, and then the answer to 7. So basically the answer to A, like the answer to 1, is equal to 1 plus the answer to 7. Answer to 7 means the answer of this part. Like if we take this A, then the answer is this. But also we can not take A. So in that case, the answer would be just answer to 2. So we'll take the maximum of that. Okay, so that is the solution here. That um, dp of I is equal to answer for suffix I. Answer of s I to n. And then finally, our final answer is dp of 0. So dp of 0 means the max number of substrings. Maximum number of substrings, right? So if dp is 0 is greater than or equal to k, like the question was initially that we have to take at least k substrings, right? So if dp of 0 is greater than or equal to k, then return true, otherwise return false. All right. So if it is still not clear, I'll just try to dry run this on this string here. Okay. So we have this string here, ABCD F ABCD AE ABCD, okay, BAE FAB. So the index is 0, 1, 2, 3, 5, 6, 7, 8, and 9. And the ans. So the answer to the indices. So first I will calculate the answer for this one, the last index. So the answer for this one is actually 0. Why? Because we cannot actually take this B. And why we cannot take this B? Because the first occurrence is not here. This is not the first occurrence, so we cannot take this B. Okay. Now this A. We actually cannot take this A. So therefore the answer is 0. Alright. Now we have this F. So actually we can take F, right? And if we want to take F, then we have to take only this. Like there is no compulsion to take any more characters because the only occurrence of F is this one. Okay. So therefore the answer is 1. We have found one substring. That is 1 plus answer of 8. See, we are at index 7, right? And if you want to take this index, then I have to go till here only. So ans of 7 will be equal to 1 plus ans of 8, which is equal to 1. So we have 1 here. Now this E. If I want to take this E, then I have to take this thing here, right? So the answer to the index 6 is equal to 1 plus answer to this whole. All right. So the answer is 2, and so on. And so on we can calculate. So if I just calculate it, so this will be 2 because we cannot take this A. We cannot take this B. We can take this D. We can take this C. Now, okay, now it is interesting. Okay, so let's say I want to take this B. Okay, let's say I want to start from this B. Then can I do that? Let's see. If I want to start from this B, then I have to go till the end, right? Because the last occurrence of B is there. But now I have taken this A also. But the first occurrence of A is not here. The first occurrence of A was before 1. It is at 0. So that's why actually I cannot take this B. So since I cannot take this B, the answer to this like is just answer to this one, which is equal to 4. And similarly, answer to this is also answer to this is also answer to this one. So it is 4. So in the end, the answer like the 4 is greater than or equal to 2. So that's why we return true. Okay. So like that is the logic here. So I'll show you guys the code. Okay. So in the code, what I have done is I have made a vector. Like I have made a position vector that what are all the positions in which the characters are. So there is this position vector which contains all of the positions of all the characters. So pos of I is all the list of all the positions of character I. Okay. So I'm using this vector to keep track of what are the positions, like what is the starting and ending position of each character, right? So pos of s of I minus a dot pushback I for int I equal to 0 as an I plus plus. And also I have a vector of bool is first. So is first means that um like basically that index is that the first occurrence of that character. So is first of 1 will be true in this case. So is first of 1 is equal to true because the first, so because B is here and this is the first occurrence of this B, right? So I make an is first vector, and for int I equals to 0 I represent 26 I plus plus. So what I just do is I iterate over all the characters and their first position I mark true. Is first of position I is equal to true. And now what I'll just do is I'll just calculate the dp. So I have made a dp vector of n plus 1, which is the answer, like dpi is the answer for the substring I to n. Okay. So if is first of I, so if it is the first occurrence of I, then we can take that character, right? Otherwise we cannot take that character. So now I'll run a loop from starting from I. Okay. So I'll just take this example a b a e b e d c. So let's say we are at I equals to here. Okay. So since this is the first occurrence of A, I will try to see that till where do I have to take. Okay. So I'll start a loop from j equal to I. Like I is currently the pointer I is here, right? So I'll start a loop from j equal to I and I'll go till wherever I have to go. So j equal to I and int mi is equal to pos of si minus a dot back. So what does this mean? This means that at least I have to go till the last position of si. Like I am taking si, right? So I at least have to go till the last position of si. So that's what it means. That I have to go till mi. And bool flag equals to true. This flag means that is it a valid? So I'll use that flag later on. So while j is less than mi. So while we are not at the minimum index that we have to go. So we are at 0, right? And we have to go till 2. So since j is less than 2, we have to keep updating. We have to keep moving forward. So while j is less than mi, we'll do j plus plus. Okay. So we go to this 1. Like now j is at this point. Okay, so now j is here, so we are taking this b. But now we have to update that since we have taken a b, we have to take the last b also. So mi is equal to max of mi comma pos sj dot back. Like since we have taken this b, we have to take the last occurrence of b as well. So we have updated the mi that till where do we have to go. So now we have to go till here actually. Earlier we were trying to go till here only, but now we have to go till here, right? Since we have taken the b also. And also since we are taking b, we have to check that is there an occurrence of b before I. Like since we are starting from I, so is there an occurrence before I? If there is, then actually we cannot start from I. So if pos of sj of 0, so the first occurrence of sj, if it is less than I, if it is before I, then flag equals false and then break. Okay, so I am doing this because that is a contradiction. Like we are starting from I and we have taken sj, but the first occurrence of sj is before I, so we actually cannot start from I. Okay, so if flag, like if flag, then I update the dp. So if flag, then dp I equals to dp of j plus 1 plus 1. So what does this mean? That okay, um right, so this mi becomes updated to this character. So 0 1 2 3 4. So mi becomes 4, right? So we go ahead, we go to this 2, then we go to this e. So now here mi becomes equal to 5. Then we go to this 4, j is equal to 4, and then j equal to 5. So since j is not less than 5 now, while loop will terminate. So we have gone till j equal to 5. So we have basically taken the substring from I to j. So we can actually look at the answer from j plus 1 and add 1 to it. So this is one substring. So a2 is one substring. So 1 plus ans of j plus 1. Like since we have ended up at j here, we have to take the answer for j plus 1. So dp of I equals to ans for dp of j plus 1 plus 1. Okay. But actually we cannot have this if I is equal to 0 and j equal to n minus 1, because that means that we have taken the whole string, and the whole string is not a special substring by definition. The substring is not the entire string, then only it is special. So if this is not, if it is not the whole string, and if flag is true, then I just said dpi equals to dp of j plus 1 plus 1. So this is the case if we take the ith element. So like this entire code was to check the case for if we take the ith element, but if we don't take the ith element, then it is the answer for I plus 1. So dpi is either dp of I plus 1, that means we don't take the ith element, or if we take the ith element, then this is the code for that, right? And this code is O of n, but it will only run for all the occurrences of the first. Like it will only run if the index has the first occurrence of that character. So if it is first, then only it will run. So it will at most run 26 times. So actually this is not O of n square. This entire thing is not n square. It is O of n only, because this while loop, like or this if statement runs only 26 times at max. So this is the code where we if we take the index I, and this is the code if we don't take the index I. Okay, and we need to take the maximum of both as the answer. And this is just debugging for debugging purpose, just ignore that. And then the final answer is dp of 0. So dp of 0 means that till, like, what is the answer for the whole entire string, right? And if that is greater than or equal to k, then we return true, otherwise we return false. All right, so yeah, that was the code. And so now if you have any doubt in this one, then just let me know. So any doubts, anyone? Okay, I am assuming there are no doubts here, so I'll move on to the next problem. All right. Length of longest V-shaped diagonal segment. You are given a 2D integer matrix grid of size n by m, where each element is either 0, 1, or 2. A V-shaped diagonal segment is defined as the segment starts with 1. The subsequent segments follows this infinite sequence. So 2, 0, 2, 0, 2, 0. It has to alternate between 2s and 0s. The segment starts along a diagonal direction, either top left to bottom right. So like either of the four directions. So like either we can go here, either we can go here, or we can go here, or we can go here. So it starts with either of these four directions, and then it continues the sequence in the same diagonal direction. It continues in the same direction, and it makes at most one clockwise turn, 90-degree clockwise turn to another diagonal direction while maintaining the sequence. So let's say we are at this index, like we are here, like we are moving in this direction. Then we can do at most one right turn. So we can move here now. So that is allowed. Okay. And also we have to ensure that it starts with 1 and follows 2 0 2 0 2 0. Like on the grid we have to traverse like that. So return the length of the longest V-shaped diagonal segment. If no valid segment exists, then return 0. Okay. So let's look at the samples to understand the question better. Okay. So let's start from 1. So they are saying that you start from this 1 and start in the bottom left direction. So if you start like this, bottom left, and then you make a right turn, 90-degree, clockwise right turn. So you go here and then you go here. And then you actually cannot make another turn because you can only make one turn. So kind of this makes a V shape, like this makes a V shape, right? So that's why they are calling it V-shaped diagonal segment, and it is diagonal also. So since it is diagonal and V-shaped, they are calling it V-shaped diagonal segment. So and also it follows the pattern of 1 2 0 2 0. So that should be followed, either 1 2 0 2 0 or 1 2 0 2, like whatever. It has to follow like alternatingly 0 and 2, and starts with 1, right? So in this case, the maximum length is 5. 1 2 3 4 and 5. Now let's take a look at another example. In this one, we have to start from here, this one, and go to the bottom left, like top right to bottom direction. We have to go from here to here, and then we can make a clockwise turn. So either actually we could have gone in the same direction, which is 0, but then after that we cannot make a turn because here is 1. There should have been 2. So if we had gone to this 0, then we would have only have length of 3. But here actually we can take a turn. So 1 2, and we take a turn. So 0 and continue in the same direction. So 2. So in this case we have a length of 4, right? So we have a length of 4. So therefore 4 is the answer for this test case. And example number 3, the grid is like this. So there's only one. There's only one. So we start from this one, and diagonally we go down. So 1 2 0 2 0, and we don't take a turn. So actually we could take a turn here also. 1 2 0 2 0. So we can do that as well. So take a turn here. In both the cases, answer is 5, right? So we could do that as well. An example 4, input grid is 1. So it just has a single 1. So you start from this 1, and it is the only single element in the sequence. So the output is 1. The length of the sequence is 1. So we have been given n and m, like we have been given a grid of size n by m, and we have to print the maximum length that we can achieve, right? So actually this is pretty simple DP question. Like actually you can do it recursively, right? So let's say, let's say you have a grid. Let's say there is a 1 here, and you want to start from here. So let's say this is the only one in this entire grid. Okay, and there is a 0 here, there's a 2 here, there's a 2 here, and there's a 2 here. So definitely you cannot go in this direction. From 1 to 0 you cannot go, right? From 1 to 2 you can go, and from 1 to 2 you can go, and from 1 to 2 you can go. So you have three options right here, right? So you can basically check all of them. So if you go here, then what is the answer? If you go here, then what is the answer? And if you go here, then what is the answer? All right. So let's say if you go here, then on this case, like on this cell, you have two options, to either go here or to go here. Like basically, you can either go here in the same direction, or you can make a clockwise turn, right? So let's say there is not a 0 here. So let's say there is a 2 here and a 0 here. So definitely you have to take a right turn, a clockwise turn here. Now you have only one option. You have only one option to go to this 2. Like if there's a 2 here, let's say there was not a 2 here, let's say there's a 0 here, then you can't do anything, because you have gone from 1 to this 2, then you have taken a turn. So now that you have taken a turn, you have to go in the same direction only. So from 0 you can't take a turn again, because you can take only one turn, right? So that's why you cannot take a turn, and the answer to this is actually 3. Like name, like not the answer, but if we go, if we start from this 1 and go to here, then the answer is 3. Okay. So that is one case. But what if we try to go to this 2? Like if we go to this 2, then also we'll calculate the answer, and if we go to this 2, then also we'll calculate the answer recursively, and then we can just take the maximum of it. So isn't this just recursion? Like if I just search all the possibilities, like what I can just do is I can keep track of what direction I am going in. Okay, so there are four directions, right? There are four directions, so let's call this direction 1, let's call this one direction 2, this one as direction 3, and this one as direction 4, right? So if we are going in direction 1, then like if we are going in direction 1 and we have either, like let's say we have not yet made a turn, so we can make a turn only once, right? Turn only once we can do. So that means that if I have not yet taken a turn and I'm going in direction 1, then actually I can go to direction 2 now. Like I can actually go to direction 2, or I can continue with direction 1. So what I can just do is I can keep track of the fact that what direction I'm going in right now, and also what is, like, have I made a turn or not? Like have I made any turns or not till now? So if I start from here and I go here, so that means I am currently in direction number 1 and I have not made a turn. So basically false, right? And also let's just store the index also. So I'll just number this 0 1 2 3 4 and 0 1 2 3 4 and 5, right? So from starting from this one, what we can do is, 1 minute. Yeah, so starting from this one, you can go to 1 comma false. So see, this 1 1 is at 2 comma 2, right? Starting at 2 comma 2, we can go to 3 comma 1. So from the start, you can go to 3 comma 1, and also the direction is 1, and you have not yet made a turn, so false, right? Then from there, you have two options. So either you can go to here, or you can go to here, but actually you cannot go here. So you have only one option, that you have to go to 2 comma 4 comma direction is 2, so this direction, so bottom right, right? So direction is 2, and now you have made a turn true. So from this state you can go to this, and then you can go to this, and from this state you can go to, like, you have only one option because you have made a turn, right? So you can only go to this 3 comma 3, or sorry, 3 comma, see currently you are at 2 comma 4, right? So now you can only go to 3 comma 5, but actually it is not possible to go to 3 comma 5, like, because there is 0 here. There had to be 2 there if you want to go there, but there is 0, so you actually you cannot go there. So that means that you have to end up here. So the answer to this state is actually 1, and the answer to this state is 2 then, because it has only one option to go here. And so the answer is 1 plus the answer to this one. So the answer to, okay, so if we go to here, then our answer is 3. But we have other option as well, that I get either we can go here. So what does that means? So the first option is either we go to direction 1. So from start we go to direction 1, which is this case, or maybe from start we go to, this is 3 comma 3, right? Direction is 2, and we have not yet made a turn, so false. So this is one option. Or we can go from start to maybe 3 comma 1. The direction is number 3, right? And we have not yet made a turn, so false. So what I am doing is I am keeping track of the direction and whether or not I have made a turn or not, right? So that's what you can just do recursively. Like if you have done some DP problems, then you can just see that this DP is quite uh, simple to understand. Like basically, what you can just do is just transition from one state to the other. Like the transition is just 1 plus DP of other. So let's say you are at state X right now, and you can go till Y. Let's say you can go till Y or Z or W. Then the DP of X is just 1 plus max of dp of y, dp of z, and dp of w, right? And you can just compute that, like you can compute this dp. So and my states are what? My states are like the xy coordinates, like the point I comma j, and also the direction. The direction also I am keeping track of, and also a boolean. a boolean which is that have I turned or not, right? So that's why the number of states are how many? So n into m into there are four directions, and there are two possibilities that I either have turned or I have not turned. So sorry, not eight, two possibilities. So overall the number of states is just 8 into nm. Okay. And the transitions, like the transition is very easy, that let's say you are here, or let's use a new diagram. So I'll make a diagram here. So let's say you are at this state, which is 0 1 2 3, 0 1 2 3 and 4. So let's say you are at 1 comma 3, the direction is 2, and you have not turned yet, so false. So let's say you are at this state. Okay, so from here where can you go? Direction is 2, that means what? You have come from there, right? You have come from there. So either you can continue in direction 2, or you can go to direction 3. So either you can go to what is this, 2 comma 2, and the direction is still 2, and you have not turned yet, or you can turn clockwise. So you can go to what is this, 0 comma 2, and the direction is now 3. Oh sorry, wait, so this direction actually, I'll make it 3 here. So this is direction number 3, and this is direction number 4. So if you turn clockwise, the direction is 4, and now you have made a turn, so this is true. So from this one state you can actually go to these two states and take the maximum answer. But keep in mind that you can only do this if there is, like, the sequence is followed. So if you are currently at 2, like if the number written here, if the number written here is 2, then you can only go to either this or this, only if there is written 0 there, right? So also you have to check that there is 0 written there. So if in both of them it is not 0, then you cannot go to either of them. And if you cannot go to either of them, the answer is just 1. So the answer to this state is 1 if it is a leaf node. Like if it is the final state. If you cannot go anywhere from there, then the answer to it is 1. And if you can go somewhere, then the answer is just 1 plus maximum of all the possible reachable states. Right? So that's how you can just compute the DP. And as I said, my states are that um, where, like, the coordinates, x coordinate, y coordinate, and the current direction that you are moving in, and whether or not you have turned or not currently. So yeah, that is the DP, and the transition is also simple. So to be honest, this question is simpler than the problem 3 actually. Like in problem 3 there were multiple things that you have to ensure, but in this problem 4 it is actually pretty simple. Like there are some states, the only thing to think about is the state here, that you have to keep track of where you are and the direction, and also whether or not you have turned. So if you have these four states, then you can easily figure it out the transitions. And then what is the final answer? Final answer is like you just iterate over all the cells. Like you can just iterate over all the starting positions. So you have to start from 1, right? You have to start from 1. So you just iterate over all the ones. So just iterate over all the positions, and wherever there is 1, just check all the directions. Okay, so all the possible directions you will check, and wherever there is 2, so 1 ke baad there should be 2, right? The sequence should be like 1 2 0 2 0 etc. So wherever there is 2, you will just check their answer, so their DP. And you can simply write a recursive DP, because iterative is not really possible in this case, because we don't know that what is the order that we have to ensure, right? So just write a recursive DP, and it should be pretty simple. Okay. So the complexity of this is just n into m. Why? Because there are 8 into nm states, and at max there can be two transitions from each state. Like, because I told you now that if you are at 133 comma false, then you can either go to 222 comma false, or you can go to 0 comma 2 comma 4 comma true. So if you are at a false state, then you can either keep moving in the same direction, or you can turn and go to a true state. So for all the false states, there are two transitions, and for all the true states, there is only one transition, that you have only one option, that you can keep moving in the same direction, right? So yeah, so at max we have two transitions, so 16 nm transitions, you can say. So the time complexity is basically O of m into n, and O of m into n will easily pass, right? Okay. So I think that is the logic here, and I'll just show you the code. So I have these recursive functions. Actually, I have two functions, one for true and one for false. Like, I could have just taken another parameter, that is that bool has turned. Like, I could have done that also, but I have not done that. I have just made two different DP vectors. So I have one DP as I have not made a turn yet, and the another DP as I have made a turn, the DP2. Okay. So I have these two functions, recursive functions, which calculate the DP. All right. So ans1 of I, j, and direction, and ans1 means it is false currently. Turn is not made yet. So if dp1 of I, j direction is not equal to -1, like, if it is memoized, then just return it. Right. This is the the first step. Now, if we have not yet calculated the answer to this, then we have two possibilities, right? Either we can continue same direction, that is, if we are at in this direction, we are go to the same direction. So the new coordinates are I plus dx of dir and I plus j plus dy of dir. So what is it, dx dy? Dx and dy are just two vectors that I made here. Okay. So basically the first direction is 1 1. So 1 1 means um, one increase in x and one increase in y both. Then the second direction is 1 comma minus 1. So x will be incremented, but y will be decremented. So that is second direction. The third direction is minus 1, and fourth direction is -1 comma 1. So that is the vector that I have made. So easily using that, I can calculate my new directions. So if I continue in same direction, then x is equal to, like, the my new coordinate is the current coordinate plus dx of direction, and new y coordinate is current y coordinate plus dy of direction. And if x comma y is valid, so is valid means that it is in the bounds, like it is inside the grid, and ax comma ay is equal to 2 minus ai comma aj. So what does this mean? That if ai comma aj is 0, then ax comma ay has to be 2, right? And if ai comma aj is 2, then ax comma ay has to be 0. So that's why I am checking that if ax comma ay is 2 minus ai comma aj, then only I can go to x comma y, right? So I can go to x comma y. So ans1 of x y comma direction. So 1 plus ans1. That is the ans for this. That is one possible answer for this. So ans equals max of this. So this is one possibility, that I continue in same direction, and another possibility that I make a clockwise turn. So in that What is the new direction? It is direction plus 1 modulo 4. So actually I have defined it like that only, that the direction 1 is 1 1, right? So direction 0 is that, direction 1 is this, direction 2 is this, and direction 3 is this. So a clockwise turn is just, so if currently I am at direction, then the new direction is direction plus 1. Sorry, like if it is 0, then after clockwise it is 1. And so, but if it is 3, then after clockwise it is 0. So direction plus 1 modulo 4. Okay. So the new direction is direction plus 1 mod 4. And my new x is equal to I plus dx of new direction. Y is equal to j plus dy of new direction. Now if it is valid, and a of xy is equal to 2 minus a of ij, then ans equals max of ans, comma ans 2 of xy new direction. So ans 2 is just that I have already made a turn. Like I have two dp's, right? One dp is that I have not made a turn, and another dp is that I have made a turn. So this ans 2 is that we cannot make another turn. So I'm calling ans 2 with the new variables, that are the new x, the new y, and new direction. So whatever the answer is, plus 1 I will do. So that is the answer to this one. So I'll take the max and I'll return ans. Like I'll just return this and also store it in the dp1 vector, so that in the future we don't have to recalculate it. All right. So that is the case where we have not made a turn yet, right? And what if we have already made a turn? If we have already made a turn, then it is pretty simple. So again, the first thing we check is that if we have already calculated the answer, then return dp2. Okay. And otherwise, just calculate the answer. So how do we calculate it? That we have to go in the same direction only. So int x equals to I plus dx of dir, and int y equal to j plus dy of dir. So we have to move in same direction. And if direction that final coordinate is valid, if it is invalid, like if it is out of the grid, so what does that mean? That means that suppose we are moving in this direction. Let's say we move from here to here, and we have already made a turn. So the boolean is true, and we are here. Then we have to go here, right? But this is out of the square, so therefore it is not valid. So that's what it is checking right here. That if it is not valid, then the answer is just 1. Like the only square that we can go is this. So the answer to this square is just 1. This particular square only. And if it is valid, then if another thing that we need to check, that let's say if it is valid, that let's say we came here, or not here, wait. Let's say we came here from here. So we have to go here, right? So this is valid. But also we have to ensure that there is 2 and there is 0. Or there is uh, either 2 or 0, or 0 or 2, right? So we have to ensure that as well. So if axy equal to 2 minus aij, then we will return ans2 plus 1, like ans2 of xy dir plus 1, and we store it in dp2 as well. Otherwise we return 1, because we have only one option to go to that cell, but actually we cannot go there because the number is not satisfied. So in that case we return 1. Yes. So that is my second case, that we have already made a turn. Okay. So that's the two dps. And then I'll to find the final answer, what we can just do is we can just iterate over all the possible values of the starting point. So I'll iterate over all ij, and if aij equals 1, then that means I can start from there, right? So I'll start from there and I'll check all the four possible directions. So I'll check all the four directions. Int x equals to I plus dx of k, and int y equals to j plus dy of k. So if is valid xy and axy equals to 2, so from 1 we can go to 2, right? Like the sequence has to be like 1 2 0 2020. So we have to go to 2. So if it is valid and if the number is 2, then we can go there. So ans equals max of ans, comma ans 1 of xyk plus 1. So why ans 1? Because we have not made a turn yet. We're just starting now. So that's why I'm calling this with false. So ans 1 plus 1. Okay. But it can also happen that there was no 2. Like this condition was not satisfied for any direction. So in that case, the answer is just 1. So I take the max with 1. That if I'm able to find aij equal to 1, then the answer is at least 1, right? So I just take the max with 1 and then I'll just in the end return answer. All right. So that is the DP here. That is a pretty simple like DP question that just keep track of I, J, direction, and whether or not you have turned right now. So like if you have practiced many DP questions, this one must be very easy for you. Okay, so that is the solution. So if it is clear, then just let me know, or if there are any doubts. So is there any doubt to any of you? So do any of you have a doubt, or is this good? Like, or should I end it now? Okay, so I don't see any questions in the chat, so I'm assuming that every one of you got it. So I'll just end the PCD now. So all right, guys, thanks for joining, and I'll see you guys next time.